Hello, welcome to the InMage Solutions presentation of protecting SharePoint on Hyper-V. Just a quick overview. InMage was founded in 2002 by Kumar Malavalli, which was also the founder of Brocade Communications. The focus of InMage is we are a software company dedicated to data replication. That's all we do is replicate and migrate data from point A to point B. The product that we'll talk about today is the InMage Scout product. We're based in the United States, in Santa Clara, and we have offices around the country as well as worldwide. We have multiple patents around the technology that we will be discussing today. And what that technology is CDP, or Continuous Data Protection. Whether it's a heterogeneous environment for disaster recovery or simply just continuous data replication for disk backup. We like to remind everybody that a disaster is not necessarily a huge event. It's not necessarily that earthquake or that tornado or hurricane, but the reality of it is the majority of the disasters happen in the data center themselves. Whether it's power failure, hardware failure, even human error ranks towards the top. And InMage can protect the entire environment, or it can protect that specific single server that you're looking to protect. Regardless of what the needs are, we can replicate and we can fail over one or many servers in your environment to protect you against all kinds of disaster recovery needs. InMage is a network-based, block-level, asynchronous, continuous replication solution. So network-based meaning that it is simple TCP/IP communications within your environment. There's really no changes that need to take place within the organization to allow InMage to replicate its information from point A to point B. It is block level at the disk level, so we're monitoring the block changes as they occur real time, and we're replicating and sending those block changes real time to the target location, whether it's local or remote. Asynchronous simply means there's no distance limitation. We can send that data to the cabinet next door, or we can send it around the world, or we can send it to both locations at the same time. And its continuous replication solution means that we're monitoring every single millisecond as it occurs. We want to make sure that we're capturing all the data, and we're actually transmitting just the deltas of the blocks as they occur and as they're changed. So the 5 critical areas that InMage focuses on in disaster recovery, whether it's a full site failover or a full site outage, we're there to protect you. We can protect multiple servers. We can protect single servers. We can also protect applications that span multiple servers, such as SharePoint. SharePoint typically has a database component, application component, and a file component. Typically those are spread across multiple servers, and so we can certainly protect and recover the entire SharePoint environment, whether it's on one server or whether it's spread across multiple servers. The reason to be able to protect applications is our capability of taking application consistency points. With application consistency, that's the key to protecting SharePoint. Being able to work with the Microsoft VSS service to create that consistent state across one or multiple servers allows us to give full environmental protection to SharePoint. So you have the ability to not only roll back to any point in time down to the millisecond with CDP, but you also have that capability of presenting that data at a known consistency point. By working with the Microsoft VSS, the Volume Shadow Copy Service, we are taking the very first step of VSS, which is to create a consistent state by flushing any pending writes down to disk. Then InMage understands which writes those are at a block level and can insert a flag or a marker immediately after that last block of change for consistency. And it can also do this and span multiple servers for the environment. Whether you're doing local continuous backup or you're doing local continuous recovery, whether it's remote or local, it doesn't matter. We're able to not only replicate locally, but replicate remotely at the same time, or one or the other. It's the same actions, the same screenshots that you'll be working with. So it's very easy, regardless of what that environmental needs are. We can also do backup and recovery for mixed environments, whether they're physical or virtual environments. Certainly we're talking about Microsoft Hyper-V in this webinar, and we will focus heavily on that, but we do also work with VMware and Citrix Xen Server, as well as with some lesser known virtualization agents too. We certainly support Windows, as we'll discuss today, but there's also support for Linux and Unix, as well as we do work with cloud vendors and cloud providers for that remote location. Whether it's block or file replication or whether it's WAN optimization, it's all built into the product. So WAN optimization is included as part of the product so that you can control how that information and how that data is going to be replicated to the remote site. We also have SLA monitoring, whether it's text-based or graphical. We give you real-time RPO numbers so you can see exactly what's going on within the environment, even down to the logical volume level. So you know exactly how long it's taking for that information to get from point A to point B. We also have new technology that we call the sparse retention. Essentially, when you're doing CDP protection, you're copying every millisecond of data to that remote site, and you're tracking the order of operations of which that write information has occurred. So if you wanted to keep a long period of time, say a year's worth of retention, it actually uses a fair amount of data just to keep track of all of that information at every millisecond interval. So by providing sparse retention capabilities, you can optionally enable the capability to retain your data or retain fewer application points for older data. Essentially what this means is you can set up a policy, for example, that says during the first week you want to have full and true CDP protection, meaning every millisecond of data is going to be protected. Then perhaps the week after that you only want to maintain an hourly recovery point. Perhaps the following week you want to have a daily recovery point, then maybe a weekly recovery point, and then maybe just a monthly recovery point for the remainder of the year. You have full control on an individual server basis or a global basis to set a policy such as this. And we're only replicating the changed blocks. We want to keep that recovery point objective and the amount of bandwidth used very low by only sending the deltas of those changed blocks. We're not even sending full blocks over to that remote site. Also, there's no rehydration needed from a deduplication process. InMage does not deduplicate that data. Working at a block level, there's really not much need to deduplicate that data. Also, we really want to focus on that recovery time objective and keeping that low by not having to rehydrate that data or be worried about if there's enough white disk space available to rehydrate that data before it's in use. So with InMage, when you fell over, it's just a matter of presenting that data and directing traffic to that secondary site. We also have many more applications that we protect outside of SharePoint, whether it's Exchange or SQL or Oracle, MySQL, even BlackBerry Enterprise servers in there, as well as many other applications you'd find in the enterprise environment. Really, the whole goal is to minimize downtime and data loss. Really, we're focused on that recovery point and recovery time objective to bring it both as close to zero as possible. Here's a generic overview of what the environment may look like. InMage is a host offload solution. There is a data tap that resides on the servers, and there is a second tier of architecture called the process server. That second tier of architecture does all the heavy lifting. Does the caching, queuing, compression, WAN acceleration, bandwidth management, SLA monitoring and reporting. It does all the heavy lifting that's needed in order to have a successful replication. The InMage data tap, which resides on the server, is actually just passively monitoring for write I/O and sending that write I/O over to the process server to be handled and replicated remotely. It's also working with the VSS writer, and in the case of Microsoft, to ensure that there is consistency information there. In this generic example, we have 6 physical servers replicating into a secondary site, 5 of which are virtualized, and 1 of them is physical. Now, the following slides we will become very specific to Hyper-V and how that replication works, but this is very generic here of the replication into a guest environment. There is a data tap on the remote site as well. It auto-trains itself to send or receive that data, and that data tap on the remote side will actually unapply any policy set by the process server before it lays that information down at a block level onto the disk. So you do have an identical copy at the logical volume level. In addition, there's a control server on that secondary site. The control server is actually where the web UI resides. That control server controls the entire replication environment. If your environment were to scale out or you were to have multiple sites, you may have multiple process servers. That control server continues a parent relationship across all the process servers to ensure that you have a central point or a single pane of glass to control and manage the entire environment as it scales out. We also have the capability to simplify backup. by creating a dedicated backup target, providing the appropriate amount of storage, and then using whatever backup agent is already available in your environment. We can simply simplify that backup or archive to tape process by using InMage replication. Perhaps you're keeping 30 or 60 days of retention, and then you simply use a simple agent that does not need any application integration capability, and you also can just leverage full backups rather than dealing with any kind of tape rotation style. What would happen is you simply present the volumes at a consistency point, hand those volumes off to the backup agent to archive it down to tape. Once that archive's done, you do simple full archive, you can ship that off site, and you release the mount point of the InMage replication. And you can continue to do this and do just simply full backups rather than any other tape backup rotation. We'll now get into slides very specific to Hyper-V, and this is how we set up the replication and protection. You'll notice we have a process server and we have the control server still in here. We have a primary server at the hypervisor level with some guest machines running, and on the remote site we have a hypervisor as well, and perhaps there's some running guests over there also. It doesn't matter. The InMage data taps will install themselves directly on the hypervisor level, so they're installed on the Hyper-V machine only, not on the guests. We also provision the appropriate amount of storage on the remote site hypervisor, and then we simply replicate the appropriate volumes that are correlated to the servers that you want to protect into the new storage that's been allocated on the remote site. And this is how you'll stand on a day-by-day basis of protection, simply replicating the logical volumes from the hypervisor server to a remote hypervisor server. When we talk about failover or recovery, you essentially have everything established and you're replicating. You simply select the machine that you would like to recover. You then select whether it's a planned or an unplanned failover. A planned failover is just that. It's a planned event where you are failing over for perhaps maintenance purposes or migrating data. And the difference between planned and unplanned is how the consistency points work. Remember, we're taking those application level consistency points. Well, if you choose a planned failover, we will take a consistency point immediately at the time of failover so that you lose absolutely no data. We'll replicate that consistency point to the secondary site and present the storage at that point in time. An unplanned failover will actually use the last known good consistency point that is available to that remote target server. Once that consistency point is found and the point in time that you wish to recover, we will roll back the specific storage for that guest machine to the specific time that was requested. At that point, we simply start the guest machine with the Hyper-V manager and to present that server, and then users can simply connect in and start using that machine. At this time, it is a destructive failover, so we do break replication behind the scenes. So replication is actually not occurring right now to that volume. It is dedicated to that guest machine and receiving updates. There is a failback process, essentially the same process in reverse, so that you can capture any updates that were made on the secondary site and you can bring them back to the primary site once the issue has been resolved. We also have the capability to do non-destructive DR testing. So non-destructive DR testing essentially is very, very similar to a failover. However, we do not break replication during the process. Essentially, you will select the recovery point or the consistency point that you desire. We'll then present the guest non-destructively. We'll actually take a virtual copy of the point in time that was requested. Users then have access to that running guest machine. It'll be full read-write access, so you can run queries or execute anything you need to against that guest machine. Replication is still running in the background to the storage. Because we're using a virtual snapshot of the data at the point in time requested, it has not broke the replication. The virtual snapshot and DR test don't require additional storage. It's simply referencing that point in time. And then once you're done, the snapshots are removed and the replication continues in the background. The replication never stopped, so you can freely and easily test your DR scenario without having to worry about breaking replication, reestablishing replication, what were to happen if an actual disaster occurred while you were doing your DR test. So providing the ability to do non-destructive DR testing is very helpful. Today we're going to connect into a lab. We'll talk about the Unified Manager interface, the web UI. We'll also look at the simplified RPO RTO and how you can get up to real-time updates of exactly what that RPO and RTO are. And we'll also do a quick shortened version of a virtual machine failover so we can fit within our time frame. Okay, here we are in the user interface of the InMage replication. So as you can see here, we simply are welcomed with a high-level dashboard where we can see we have a couple of SharePoint environments being replicated and protected in this lab. We have a SharePoint 2012 as well as SharePoint running on 2008. This green circle here is actually a pie chart that'll highlight if there's any issues or warnings. It's simply all green because everything's happy. If we select our SharePoint 2012 replication pair, you'll notice that we are monitoring the T drive. Again, this is at the hypervisor level, so the T drive actually correlates to the server that's hosting SharePoint 2012 on it. You can see that we have a real-time RPO, recovery point objective value, that's being represented to us. This screen will auto refresh itself every 60 seconds. That's configurable if you'd like to be more aggressive, but that recovery point objective number will update for us as the screen goes on. We have primary readiness checks as well as secondary readiness checks, basically checking for dependencies of the SharePoint application so we can ensure that when we do fail over it will be successful. And certainly we're taking consistency points every 10 minutes in this case. You can set that consistency point interval to be more or less aggressive based on what your needs are. We also have recovery scenarios pre-created, whether they're planned, unplanned. We have failback, fast failback, and as well as a DR exercise as some of the options that are available for us. So what I'm going to do is we'll connect into our SharePoint server right now. I'm connected into the SharePoint server, and I'll just simply demonstrate that it is active and we're able to navigate around within the server itself and look at some items that are here. The next thing I want to do is I want to take this server down as a disaster. I'm going to connect into the Hyper-V Manager, and here is our SharePoint 2012 server. I'm going to turn it off, basically just power down the machine. Certainly I am sure that I want to create a disaster, and so I did not turn it off nice or anything. I just crashed the server, similar to pulling the power. At this point we now have a disaster and are unable to actually interact in any way with the application and the server that was shared here. So what we need to do is go ahead and pull up the user interface of InMage, and we're going to manage our recovery scenarios. We're going to do an unplanned failover simply because it was an unplanned outage. I'm going to select the run option. It's telling me it has an exact flag at this time that it's going to recover to. I'll approve that. And then you have the ability to actually rerun a readiness check real time, or you can unselect that for a faster recovery. At this point, once it's activated, we can simply monitor that's in progress here. I can come and I can monitor what's going to happen. It's essentially going to roll back that volume to that last known good consistency point and present it up for us. And we'll be able to keep track of the status here. Here's the option of where I can set the screen refresh interval. I'll go ahead and make that a little bit more aggressive here so we can keep an eye on that recovery time. In this particular lab, it takes about 3.5 or 4 minutes before we go through this process of recovery. So at that time, I'll go ahead and take an opportunity to respond to a couple of the questions that have come in. Let me just review these real quick. So one of the questions that we have here says, do I have to use the sparse retention option at all times? The answer is no. The sparse retention is only available if you'd like it to be. By default, it's actually going to do true CDP replication and maintain and keep track of every millisecond of change for the period of time that you would like it retained. The sparse retention is simply an added feature which will help you to extend the livelihood and the speed of which you can recover that data when you extend it over multiple months. Do the InMage data tabs interfere with production I/O? So the question is, do the data taps interfere with the I/O? They do not. They are not a store and forward replication. They're actually passive. They're simply monitoring the write I/O as it occurs. You could think of it as like a SCSI filter driver. It's simply monitoring passively what's happening, duplicating that I/O, and handing it down to that controller, that process server, to be managed and replicated over. The next question here is, how are applications protected that are not VSS aware? That's actually a great question. We can work with applications that are not VSS aware. We simply take consistency points at the file system level. So in a Windows environment, we would work with the NTFS file system and create consistency points there. We typically see this with Lotus Notes or DB2 or some application like that. When you recover to a known file system consistency point, then those applications will be able to recover themselves and become back online. So we certainly do have the capability of working with applications even though they are not VSS aware. You can see now in the lab we have a successful failover that's created. I'll simply connect in to the hypervisor machine on the target side, and I'll just show you very quickly what it would look like from the guest or the server UI. Here's the T drive that we were protecting. You could see I could simply just navigate into this T drive right here and go ahead and extract files if I needed to. Well, certainly this is a virtual machine, so we do need to launch the machine through the Hyper-V Manager interface. So I'm at the Hyper-V Manager interface here. Here's our server that we're looking for, and I can simply go ahead and start that server. So I'll go ahead and start it now. And because we recovered to a known consistency point, the server will just go ahead and start up, and I'll connect to it at the console level so we can see what that process looks like. Because of that consistency point, we will not see any errors. It'll simply just power on the machine, and we'll be able to recover this information and interact with SharePoint very quickly. So here we are at the Control-Alt-Delete screen. I'll go ahead and simply log in. Okay, you can see that we've now logged in. I'll simply launch our Internet Explorer option. And you'll notice that we triggered the event tracking as well. So we can simply fill this out to whatever's appropriate for your environment. You'll also notice that we have a restore session option available from the browser because it is an exact copy of this server at that particular point in time. And it's going to go ahead and load our application that we have here. So when we load this application, you'll see that SharePoint is up and running. I'll just simply close this tab from thinking. We don't really need that. And in here I can open up any of these notes. It'll ask me to authenticate one more time. And once that authentication is accepted, we'll be able to access any and all capabilities within SharePoint. As you can see here, once it authenticates us, we're able to get into our post, and we actually have full read-write capabilities. SharePoint is online and available at this time, so simply add a quick note and we can save that, and you'll notice that it did update appropriately, so we do have full read-write capabilities. Again, this was a quick demonstration of showing our capabilities of failing over a Hyper-V guest machine. This one happens to have SharePoint on it, and show you that the application can quickly become online and be available. And that's the presentation that we have for today. Certainly if there's any questions, any additional questions, you can reach out to InMage at sales@inmage.com, or you can always reach us at 1-800-646-3617. I appreciate your time and attendance today. Thank you.